Assalamu alaikum students. Today we are going to revise for the summative exam which will be held on inshallah 18th of November 18th of October 2022, and you already know that we have decided to keep two chapters, chapter number 1 on absolute functions and the chapter number 2 on logarithmic functions. These two chapters are planned to revise in this summative exam. So let's start with the first chapter, which is absolute functions. So this is chapter number 1, algebra. The very first question, it is an absolute equation because we have absolute on the left and absolute on the right. So what are we going to do first? We will replace these bars by brackets, x plus 2, and the x 3x, the bar around it will be replaced by the bracket. One more thing which is added, plus minus sign, because if you put the plus minus sign around it, it will turn it into two equations. So write the two equations separately. X plus 2 1 times 3x, and x plus 2 is equals to minus 3x. Then we try to solve this equation. 3x minus x and 2 is equals to minus x plus 3x is equal to negative 2. So 2 is equals to 2x, and 2 divided by 2 will be 1. So here we got the first critical value, which is x is equal to 1. 4x is equals to negative 2, and x is equals to negative 1 over 2. These are the two critical values which satisfies this equation, absolute equation. If you want to verify in the exam, you can do this verification. Substitute x is equal to 1 in the place of x. Your left hand side should be equal to the right hand side. So 1 plus 2 is 3, the absolute of 3. 3 times 1 is 3. Everyone knows the absolute of 3 is 3. Absolute of 3 is 3. So look, left hand side becomes equal to the right hand side. X is equal to 1 is the correct solution. You can also check minus half. Is it your right solution? So minus half will be substituted in the place of x. So minus half plus 2, when you solve it, it will give you 3 over 2. And this is minus 3 over 2. The absolute of minus 3 over 2 is 3 over 2. Absolute of 3 over 2 is 3 over 2. So did you see the left hand side is equal to the right hand side? Actually, this thing is not needed, but if you want to check your answer and get confidence that you didn't do any mistake, you can substitute your answers into the calculator. Uh, you know, you can manually check it. Also, there is a function in the calculator. Let me go to that. Can you see ABS, apps? Apps mean absolute. So if I write apps x plus 2, right, and then write equal sign, alpha equal, again shift bracket close, this parenthesis, you can see that close bracket, on top of that ABS is written. So now you can write absolute 3x. Now I want to solve this equation. Shift solve. Calculator will take an initial guess, ignore it, and get your answer. So we got x is equal to 1. Now change your guess by pressing the equal sign. For example, the answer closer to 3 over 2, press 2. So now this is your guess, and calculator will take this guess and give you the nearest solution to this guess. So we got 2. Still it is giving 2. So let me change my guess to 6. Still it is giving us 1. If I give, suppose, negative 0.2, so you guys can see the answer is, oh yes, the answer, the original answer was minus half. So calculator, once we give the value closer to minus half, we got the answers. So two answers we can easily get from calculator. We can manually verify it, or algebraically we can solve the equation. The second question is absolute inequality. You will solve the absolute inequality in the same way as we solved the absolute equation. So now the first thing is replace the bars by the bracket, and replace the greater than sign in to the equal sign because we want to solve it as an equation. We write plus minus sign at the back. Now this equation gives two equations. So 4x plus 3 is equals to plus 2x minus 1, and 4x plus 3 is equals to negative 2x minus 1. 4x plus 3 is equals to 2x minus 1. 4x plus 3 is equals to, this minus will change the signs. So minus 2x plus 1. Now 4x minus 2x minus 1 minus 3, 2x minus 4, and x is equals to minus 2. This is the first critical point. 4x plus 2x, 1 minus 3, 6x is equals to minus 2, and x is equals to minus 1 over 3. After getting these two critical values, now we need to place them on the real line. So let me draw the real line here. This real line will be divided into three parts by these two critical values. Minus 2 is smaller, and then we have minus 1 over 3. Now we need to pick test points in every region. So any number which is less than minus 2. So I can choose minus 3. Between minus 2 and minus 1 over 2, I'm choosing 1 minus 1. And on the right hand side of minus 1 over 3, I'm choosing 0. These values, I'm going to plug it into the original inequality and test it. This is called testing inequality, and these points are called minus 3, minus 1, 0. They are called testing points. So let's check the first one. If I substitute 4 in the place of x minus 3 plus 3 greater than 2 minus 3 minus 1, minus 12 plus 3 gives you minus 9, minus 6 minus 1, it is minus 7. So do you think 9 is greater than 7? The answer is yes. So this is your answer. So this is true. The x less than minus 2 represents your region. So let me show you here. So this is your true solution. Now pick the value which is in between minus 2 and minus 1 over 3. Substitute it. 4 in the place of x, I put minus 1 plus 3, 2 minus 1 minus 1. So minus 4 plus 3 is minus 1. Minus 2 minus 3 is minus 3. So guys, 1 is not greater than 3, which means this is not the solution. So this is false. Now pick any value which is already taken 0, greater than minus 1 over 3. So I'm going to substitute 4, 0 plus 3, greater than 2, 0 minus 1. So absolute of 3 greater than minus 1. 3 is greater than 1. Yes, it's true. So what is the solution? The solution is all values of x which are less than minus 2, or all values of x which are greater than minus 1 over 3 is the solution of this question. And here I can pick all the values which are less than minus 2, or the values which are greater than minus 1 over 3 to satisfy this inequality. Now we need to draw the sketches for absolute functions. To draw the absolute functions, we need vertex first. Before that, we need to know the shape. We all know that the absolute functions, when we try to draw their sketch, they look like V-shaped graph. The V, uh, will be seen when there is a plus sign behind the absolute sign, or if there is a negative sign seen behind the absolute, okay, signs. So minus, at that time the V is upside down, and here you can see the absolute is positive, so you will get absolute, the face of the graph upward. So to draw the absolute functions, you must see the sign written behind the bars. So that is positive. In both cases, it is positive. So the shape is upward. Shape is like this, and this shape is also like this. Next is vertex. For the vertex, whatever you see in the denominator, in the bracket or within the bars, put it equals to 0. So 2x minus 4 is equal to 0. It gives you x is equals to 2, comma. Whatever you see outside the bars, here in this case it is 0. That is your y coordinates. So basically your vertex is 2, 0. In this case, my vertex, I need to put the thing which is in the absolute. He has written x, I put it equal to 0. So that is 0, comma. What is the value of y written over here? Negative 4. So my vertex is 0 minus 4. After finding the vertex, we need to find the y-intercept. Yani put x is equal to 0. So y is equals to absolute of minus 4, which is 4. So the graph cuts the y-axis at 4. Here the y-intercept is when I put x is equals to 0. We got y is equals to -4. If you want to make your sketch more accurate, you can also find x-intercept by putting y is equal to 0 and then try to solve this equation. 0 is equals to 2x minus 4 with plus minus sign with a 0. So x is equals to 2. It will give you x is equals to 2. Only one x-intercept it has. However, in this case, if I want to get my x-intercept, I need to put y is equals to 0. Send the -4 to the left. And then 2 is equal to absolute of x, which gives you plus -2. So there are two x-intercepts in this case. Now I want to draw my sketch. For the sketch, first thing is, what is the vertex? 2, 0. This is 2, 0. And then what is the y-intercept? 4. So I'm just going to show on the y-axis 4. I'm ready to draw the graph now. So this is your sketch for the absolute function 2x minus 4. Our x-intercept was 2, so which is already shown over here. Now come to the second question. He said vertex is 0, -4. I'm going to show here. This is -4. Y-intercept is also -4, but the x-intercept is +2 and -2. So this is -2, and this is +2. So I'm going to draw the graph passing through these 2 points. Alhamdulillah. Then you draw also the graph here. So these are the 2 sketches for the given question. So the revision for absolute equation, inequality, and the sketches is done. What are the things needed here for sketches? You need to know the shape, you need to know the vertex, y-intercept, x-intercept. 4 things if you know, you can make a very perfect sketch for absolute functions. Question number 4 is related with second part of the chapter number 1, that is related to polynomial functions. If you see, there is a polynomial whose degree is 3. The maximum power is 3. So the degree 3 polynomial is gonna be divided by a linear polynomial because the maximum power of the x is 1. We want to divide them. We have learned long division method, also comparison technique, synthetic division to do the division. But I do prefer long division when there is no unknown involved in the dividend. Look at that. When we do long division, the numerator is called dividend and the denominator is called divisor. And the thing which is seen over here, that is called quotient. And at the end, the remaining one is called remainder. And keep it in your mind, your remainder's degree is 1 degree less than the divisor. At that time, you need to stop. Now, I will write, I'll do just my long division and write the cubical polynomial in the division area where we always put the divisor. Outside we put x minus 2. Now we will focus on the first number x cubed, and here is x. We do a small division here, right? X cubed divided by x. When we cancel them, it gives us x squared. So this x squared should be written on the top. Now multiply x with x squared. When you multiply x with x squared, it gives you x power 3. So this number x cubed should be written under x cubed. Also, minus 2 is going to multiply with x squared. It gives you minus 2x squared. And this number must be written under x squared term. So I'm placing minus 2x squared. Draw the big line and do the subtraction. You have a minus sign, this changes to plus. If nothing is written, so it means plus sign, and you write a minus. Now cancel them. This is cancelled. Then minus 5 plus 2 is minus 3 x squared. Copy plus x as it is and plus 10 as it is. Repeat the same procedure. You have here minus 3x squared and outside x. Do the short division. Minus 3x squared divided by x. When you do the cancellation, it leaves you behind with minus 3x. This minus 3x, I'm going to place it here and repeat the procedure. What was the procedure? You need to multiply x with minus 3x now. When you multiply x with minus 3x, it gives you minus 3x squared. And now minus 2 is multiplying with minus 3x. Be careful, minus multiply with minus leaves you plus. 2 times 3 is 6x. So I'm going to write here 6x. Again, big line. We have we have to change the signs. The plus changes to minus and this minus changes to plus. We are going to cancel this. Now plus x minus 6x will give you minus 5x. Copy this plus 10 down. Now I'm gonna repeat the process third time. This is minus 5x and outside we have x. I'm writing minus 5x divided by x. X cancels with x and it leaves you behind minus 5. Writing here minus 5. Can you multiply now x with negative 5? So when x multiply with negative 5, it gives you minus 5x. So minus 5x. And now minus 2 is multiplying with minus 5. It leaves you 10. So plus 10. And I draw the line. Change the signs of the bottom expression. Cancel them. Wow, the remainder is 0. If the remainder is 0, we used to call that x minus 2 is a factor, and this is also a factor. How? You can write x cubed minus 5x squared plus x plus 10 equals to x minus 2 times the quotient, which is x squared minus 3x minus 5. We can use comparison method to find the quotient and the remainder. So remainder is 0. You see, this is remainder, this is quotient, and this one is your divisor, and here we have dividend. Question number 5. He said, find the remainder when a cubical polynomial is divided by 2x plus 1. Shall we go for long division Yes, we can, but long division will take more time. Rather than using long division, we have a very nice method which is called remainder theorem. When the remainder theorem is used, when you see a polynomial is divided by a linear polynomial. So from the linear expression, we try to get our critical point by putting that linear expression equal to 0. So we got the value of x minus 1 over 2. Now substitute this value minus 1 over 2 into the dividend or in the place of x, and that will finally give you the remainders. 4 in the place of x, I put minus 1 over 2 whole power 3 minus 7 minus 1 over 2 minus 1. So let's try to get it. 4 minus 1 divided by 2 raised by 3 minus 7 minus 0.5 minus 1, and the remainder is 2. Very simple question. Question number 6. He says find the remainder, and in this case, the cubical polynomial is divided by x plus 2. Both methods are in our hand. Either we go for long division or we can use remainder theorem. Let me do long division just to give you practice on long division one more time. 4x cubed plus x squared minus 3x plus 7, and I write x plus 2 outside. Now x multiply with which number to give you 4x cubed? Obviously 4x squared. 2 times 4x squared gives you 8x squared. Changing the signs. Plus 1 minus 8 is minus 7x squared. Then minus 3x. Then plus 7. Now we have here minus 7x squared divided by x will leave you minus 7x here. Plus 2 times minus 7x is minus 14x. Change the signs. 14 minus 3 is 11x. Copy plus 7 down. Now 11x divided by x leaves you 11. I'm going to write it in the quotient area. So 11x plus 22. Change the signs. And 7 minus 22 will give you minus 15. Oh man, it takes a lot of time if I use the long division. Why not I can use remainder theorem to make my procedure simple. So we prefer to use remainder theorem because our divisor is linear. As far as our divisor is linear, my suggestion is always to use the remainder theorem. So what the remainder theorem says, we need to put our divisor equals to 0. That leaves you the critical value minus 2. That minus 2, you will substitute it in the place of x. And this will be your remainder. So remainder is 4 minus 2 whole power 3 plus minus 2 whole squared minus 3 minus 2 plus 7. Now use this expression in the calculator to evaluate it and give the final answer. 4 bracket open negative 2 whole power 3 plus minus 2 squared minus 3 minus 2 plus 7. Did you see I got the answers? Minus 15, which has been already found by using long division. But long division takes more time. Remainder theorem, you just got the answer directly. Okay, guys. Now let's move to the next question. Question number 7. We have here a quadratic polynomial, and a polynomial of degree 4. It is divided by, again, a linear polynomial, and the remainder is 3. Look, in advance, the remainder is provided, and he must have left any unknown in the question. So, yes, in the dividend, he leaves a. So he will ask you to find that value of a. Again, use remainder theorem. In the remainder theorem, you need to substitute your divisor equals to 0 to get the critical value. So my critical value is half. By the use of remainder theorem, I need to substitute this critical value into the dividend in the place of x. And put it equals to 3. So did you see I substituted 1 over 2 in the place of x in the given dividend, a polynomial of degree 4, and put the whole expression equals to 3 since the remainder is 3. I need to simplify it. I may use equation solver, but at the end I will use it. Let us do it manually. 1 over 16, this is 1 over 8, this is 1 over 4, 1 over 2 minus 1 is equals to 3. Cancel. 16 cancel with 16. 1. A over 8 plus 2 minus 2 minus 1 is equals to 3. Minus 1 cancel with plus 1, minus 2 cancel with plus 2. Now, minus a over 8 is equal to 3. Substitute, not substitute, so send the 8 to 3 by cross multiplication. Minus 8 is equal to 24, and a should be negative 24. So I did all the steps, but if you want to get the answer directly from the calculator, it is possible. I'll write 16, bracket open, 0.5, whole power 4, and in the place of a, because this is unknown, I will write x, bracket open, 0.5, whole power 3, then I write plus 8, bracket open, 0.5, whole power 2, minus 4, 0.5, minus 1 equals 3. When you write this expression in the calculator, shift solve, your calculator is giving you minus 24, which we have already found it by manually solving the equation. So minus 24. Question number 8, you can see a polynomial is given to us. It is denoted by p of x because the variable contained in x is in x. It is divided by x minus 2. Look, he said factor. The word factor comes when the remainder is 0. So we have to evaluate a. The factor tells you remainder zeros. Use the remainder theorem. So x is equals to 2 is the critical value. Substitute in the place of x. And now at this time, the remainder is by default 0, and this is called factor theorem. So 8 minus 4a plus 4 plus 8 is equal to 0. So 8 plus 8, 16 plus 4, 20. Send the minus 4a to the other side. So your a is 5. We found it. You may use equation solver to solve this equation. So a part is done. B part, can I plug this value of a to factorize my polynomial completely? So x cubed minus 5x squared plus 2x plus 8 can be written as, and we saw that x minus 2 is a factor. So we want to find the quotient, the second factor. The remainder is already 0. To find this quotient, we may proceed to long division now. As you can see, I'm trying to apply the long division, and the whole procedure is same. Two time I have already explained it to you. So this time I'm silent. It was well known that the remainder will come to us 0. So what is my second factor? This is my second factor. So I'm gonna write my quotient now, x squared, but don't stop here. In the exam, you need to see maybe this quadratic expression can be further factorized into two linear factors. For this, it's better to go to the calculator, menu, equation, polynomial, degree 2, enter 1, which since the coefficient of x squared is 1, enter negative 3, the coefficient of x is negative 3, and negative 4, you put it there. The calculator is giving you the two critical values, 4 and minus 1. So the critical values, x is equals to 4 and minus 1. It means this can be further factorized. What is the factor for, and the critical value is 4? X minus 4 is the second factor, and x is equal to minus 1 is the critical value. You can write it as x plus 1. So my friends, the full answer, which I'm going to write it here, x cubed minus 5x squared plus 2x plus 8, it gives you x minus 2, x minus 4, and x plus 1. These are the three factors of this cubical polynomial, three linear factors. Didn't he say when a has this value, factorize p of x completely? This is called complete factorization. Now, question number 9. In the previous part, you saw he left only one unknown a. Now he is leaving two unknowns. A is the coefficient of x cube and b is the coefficient of x. So since two unknowns are there, he must have given two conditions to find the value of a and b. He said that when it is divided by 2x minus 1, 2x minus 1 in fact is a factor. So when the factor word is used, it means the remainder is 0. my factor theorem. So let's apply this condition. First, get your critical value by putting this divisor equal to 0. So 2x is equals to 1 and x is equals to 1 over 2. I'm going to place it there. A 0.5 raised by 3 plus squared plus b 6 is equal to 0. 0.5 whole power 3 gives you 0.125. A plus 0.5 squared gives you 0.25. 0.5b plus 6. So keep 0.125a here and 0.5b here and send 6 to the other side and also 0.25 to the other side. So it will give you 0.125a plus 0.5b minus 6.25. This is equation number 1. Second condition which he gave it to you, he said when this polynomial is divided by x minus 1, it leaves you behind with remainder minus 4. So use the remainder theorem, get the critical value first. So x is equals to 1, substitute it. So a, substitute 1 in the place of x. And now I'm going to put it equals to minus 4. So a plus 1 plus b plus 6 is equals to minus 4. A plus b minus 4 minus 6 minus 1. A plus b is equals to minus 11. Now, when I got this equation, it tells me that we have a system of two simultaneous equations to solve. Let's do. Go to the menu and find the simultaneous equations. Number 1, unknowns are 2. What is the coefficient of A? 0.125, enter. 0.5, enter. Minus 6.25, enter. The coefficient of A is 1, enter. Coefficient of B is enter. And negative 11, enter. So it leaves us A is equals to 2 and B is equals to minus 30. But for the final exam, you need to show a method. How did you get this result? The best thing is you guys can make A as a subject, minus 11 minus B, and substitute it here. So 0.125 in the place of A, you write negative 11 negative B plus 0.5B is equal to negative 6.25. Then this will help you to get the value of B equals to negative 13. And then you substitute this B in this equation. So A is equal to negative 11 negative negative 13. That gives you A is equal to 2. This you can show it to satisfy your examiner that he may thinks that you you depended only on the calculator to get the values of unknowns A and B. So at least you have shown him the technique. How did you get the values of A and B, right? Now the logarithm starts, it will be given in the other video, inshallah. Thank you.